Hello and welcome back to Compiler Programming. Now that we can write sufficiently complex programs, it would be really neat if we could also save them as executables and not just keep them around inside of C code embedded as they are right now. Now, this is not going to be a very fast process because we are not going to take any advantage of existing tooling or any other ways to create executables. So we're going to do it from scratch. So this is going to be another no coding episode. I want to very briefly talk about Windows executable file format. I'm by no means an expert in this topic, but I was able to create functioning executables from scratch before, so at least I know some of the basics of this kind of setup. Okay, so we obviously will need to have a specification, and the same way as we were looking at, for example, x64 calling convention or other specifications on MDN, you can get information about the executable format. In Windows it's called portable executable, and I think inside of it it is a variation of this common object file format. There is this page. If you look over here, you see it's 127 minutes read, and that's probably an understatement because yes, you can read through this thing in that time, but they're definitely not gonna give you sufficient understanding to probably implement this. But luckily, we don't need to implement all of it. We are just going to implement some of the basics. And so today, I just want to kind of have a brief look and explain a few things about it. So first of all, executable, it's just a binary file that it consists of some headers and some section tables that describe various things. In reality, I believe we only need two sections, namely imports and the code section, which is actually usually is inside of text one or data. Probably it is a text. Anyhow, there is this information about the section, and iData I believe is import data. Relocation is we won't need it. TLS for now we don't need it as well, and resource directory we also don't need for now, and all this stuff is probably unnecessary. There is a good kind of summary for different terminology that is used inside of this chapter or I don't know article. Basically, the important thing to understand is when we are writing an executable file, we have to deal with sort of three different addresses at the same time. One is address within the file, which is sort of more or less this thing. Then you have a virtual address, which is the address that would be in memory once the application is loaded, but because it is unstable, and remember we had this whole situation where we added support for REAP relative addressing, because like absolute addresses don't really function anymore correctly because they can be randomized. What you usually deal with is relative virtual addresses, and this is basically address. It's the same as relative instruction pointer address, except it's relative to the place where your executable is loaded in memory. So yeah, we'll see how that works later on. Now, the thing is, Windows or Microsoft really doesn't like to break backward compatibility. Like they really don't like that. And in fact, you can still run, or you could still run those programs. I'm not sure right now, 64-bit Windows probably not anymore. I'm not sure. But the point is, basically every executable is considered a DOS executable until it says it's actually not a DOS executable and it is this portable executable format. So inside of DOS header, you kind of, here they say that, inside of DOS header, you usually put a special DOS program saying, don't launch me DOS mode. And then it has a special marker here at location 3C that says, actually, no, I'm not a DOS program, I'm a portable executable. Okay, then you have a bunch of, like the first header that describes the format of the file itself with a bunch of things like the architecture, when it was created, and then there's pointers to Simultail, and then optional header. I believe we also need the optional header to be there. Yeah, we do. This is image file type, and I believe we will need to have a couple of these flags probably. And obviously we will say that our format is this one, which is pretty cute because as you can see, it's like the hex code is designed to look like 64-bit. Okay. Anyhow, we will use probably this format, these flags, and this is an executable image. Not sure if we will need to do anything else here. And yeah, so we are going to be writing out 64-bit executables, which are a bit more tricky than the 32-bit ones, but I don't think it makes any sense right now to target 32 bits, so let's just focus on the 64-bit version, even if it is a bit more complicated. Now you have a bunch of tables that say, okay, this is what it looks like, how long is certain stuff. Again, it doesn't make it easier. It's the fact that they kind of use this slash notation everywhere to say, okay, here's how big it will be if it's 32-bit versus how big it will be if it's 64-bit. So I think that 32 plus is a weird way to say 64 bits. I think they consider that it might be more than 32 at some point. I don't know. Doesn't make much sense to me, but oh well. Anyway, we have more headers specifying where stuff is. Obviously, we will need to look into detail on all of these when we will actually be implementing this stuff. But for now, just kind of scrolling through and seeing what we will need to know. And if you want to jump in and read the stuff, so you know what to pay attention to and what to skip. This section is also important, even more headers specifying what we are doing. Here it's also very important because in Windows you have this situation where you either create a console application or a GUI application. And if you create a GUI application, writing to console is really awkward. And sort of, if you create a console application, I'm not even sure you can create Windows. So like, it's this weird situation where you have to decide ahead of time if your program needs UI or doesn't. And you can see that even here that you have to provide flags to inside the executable that will tell which option are you choosing from. We don't need any other ones because it's like all specialized stuff like, I don't know. Yeah, we're definitely not building an Xbox executable at the moment. DLL characteristics are not for us. We are not going to be building DLLs. I don't think that, yeah. We're going to be consuming DLLs, but we're not going to be building DLLs. So for now, it's all goes out. Now, these are the sort of the meat of it, where we would need to fill in these data directories, particular, like we don't need export table because we are not writing an DLL or an object file. We will definitely need an import table. Later on, resource table maybe, exception table, not really. We are not writing C++, so we don't care about the exception. We don't care about certifications. This does need to be filled. The base relocation table, debug would be great to fill it at some point to simplify our debugging, but it's not strictly required for this, and not required. Well, pointer, yeah, this is also not used. We don't, probably not gonna need this as well. Not sure if we will need this one. Invert address table address size. Yes, we will definitely need these things because that's exactly the import stuff. There is this weird thing that you have import table here, but then you have it here as well. We'll get to that. It's a bit strange. Not gonna need this, not gonna need this, and not gonna need this. Yeah. Each section has its own format, so we tell what the section is, what the name of it is, what is the size, where it's supposed to be loaded, so this virtual address. Yeah, size of data on disk, pointer to that data on disk. We don't need relocations right now. This is also not the way the debugging works really right now, so it probably also can be 0. And like I said, all this is 0, 0, and characteristics is something that we can fill in. These are these section flags. You basically tell the system what is the section. Is it code? Is it not code? What is alignment of it, and so on and so forth. There's a bunch of them, but for now, we'll get to it again when we start writing all this stuff. Suffice to say that we will use this mem execute, mem read and write, and if you remember, these basically mirror what we already used for virtual alloc. Like in particular, this execute, we need to mark the memory as executable, and in when you are creating an exe file, we're basically doing it declaratively. So we're saying, okay, this is the chunk here that is code, please load it in memory and also mark this as executable for us. So internally it calls the same mechanisms as the virtual alloc would. In fact, I believe it should be possible to write exe loader inside your own program. Like you could just read this format, load the file as described by the format, mark all the pages in the right way, set up the pointers, and just run another program inside of your program. So there is nothing stopping you. There is not much point to it, other than like if you're writing a Windows compatible operating system, something like React.js or Wine emulators, right? So those people would know a lot about this format and all the quirks that it contains, but for us it's very straightforward. So yeah, this is the basics. I'm not sure we need to go into much more details. The only thing is I want to jump to this import library format, because this is where we would spend a bunch of time. Essentially, you just say, okay, I want to load that library, that DLL, and I want to load these particular functions from it. And these functions can either be specified by their number, which is faster to load, and I think it's generally it's preferred way, I'm not sure, but you could also just specify their name in ASCII, and this is the one we will be using because it's just a bit easier to specify, and also doesn't means that we don't need to figure out this information about their ordinal numbers even for common libraries. So yeah, this is the import type. We are mostly going to be interested in importing code. Basically, we are interested in calling Windows functions. And yeah, that's about it. And there is a bunch more information here. Cool. So this is a quick tour of the page itself. Another thing I want to do is look at one of the files. So I usually use a couple of programs to deal with this PE stuff. Failalizer is pretty good one. It's completely not optimized for high resolution screens, so it might look slightly awkward, and I can't really zoom in or anything else. So sorry about that. But basically, once you load a file in it, you can go to where is this? You can have these. So mz header is this MS-DOS header, and then you can go to p header, and it shows you a bunch of information about all this stuff, and we will actually basically use this to debug our stuff, right? You can also look at each particular section. So there is text. Our data is relocation data. Then you have data is, I believe, and the non-constant data. I'm not sure about p data. I data is import stuff. Let me get back to this. Config, no idea. And you have more relocation stuff. And it also tells you what is the what are the flags on it, basically. So anyway, text is actually our executable stuff, so our code of our program. And I believe if I click over here, I'm not sure if I can force it to disassemble this. There was definitely a disassembler here, but I will need to tell it the right address, and I'm not sure in which format do I need to put this address. Do I need to say something like this? Not entirely sure. Anyway, this is not important for now. For this assembler, we actually can use Visual Studio, and it's gonna be better one anyway. So here we are only mostly interested in this stuff here and the sections. Imports is interesting, and if you notice, basically what I opened is I opened our one of the executables that we created with the tests, and this executable actually has only one import, and that import is gets the handle, which is slightly weird. I think it should have more of them. So maybe let me try to open this up in another program. So yeah, Finalizer and this Pepper are both free programs, so you can just download them and play around. I will link to both in the description below the video, so you can check it out. This is a bit more bare bones program, I'd say, but in a way it's also nice because it provides really raw information about the executable. And if we look into import directory, yeah, actually, so this was right that it only has kernel 32, but it's totally wrong that only one import. In reality, we will load all of these functions here. So, and remember I mentioned, so there is this ordinal number, there is function name, but if it's 0, this one is used for lookups, but this is sort of faster to do it this way. But yeah, we're not going to worry about this one. Yeah, so as you can see, we use quite a bit of stuff. Well, this is getting standard outputs, virtual alloc, virtual free, obviously for managing memory. I have no idea what these two are. I believe this is for the exception stuff, more exception stuff, process information, probably for arguments to quit the process. No idea about this one. This is timer stuff, bunch of things about the process, and so on and so forth. So there is like a bunch of things that libc runtime is loading, because obviously we weren't the ones that were getting this, but we actually won't need majority of that. In Hello World program, which will take quite a bit to get to, we will probably need a read file. We will need get std handle. We probably need the write file. Yeah, actually we don't even need read file. We just need write file. We need exit process definitely, and this would be the first program that we'll probably ever write. It will literally just called exit process, because the thing is, in C, like if I go to Godbolt or Compile Explorer, so when you have this stuff, you would think that this is how the program actually works. That's when you say return, you actually just return and everything is fine, but it's actually not true. The thing is, your like main is an entry point for libc, but it's not the entry point for the executable file. And libc calls you and uses this number here that you return to call exit process. But even if you don't call exit process, you like, even though your code actually is done, your process is just gonna stay in a zombie state and never terminate. So if we want to have a program that literally just exits, we already will need a library function, which is kind of interesting and maybe not what you would expect out of this setup. Anyway, yeah, so I said exception directory, we are not gonna need this. Relocations, we will not need it for now. Debug stuff, not needed for now. Load, not need. And this is the same stuff as here. Yep, so this is what we're going to be using. I'm not sure if we will use this program or Filealyzer or some combination of both, but we definitely will need things that can help us debug the Windows executables. Probably in the next episode, I will start slowly chipping away at creating an executable. I guess we will follow the same format as we did with execution itself. So first we will try to just figure out what are the minimal bytes we can write out to actually have something working, and then we will continue from there. But next few episodes will definitely be quite sizable and quite tricky to get right. So lots of frustrating debugging ahead. For now, though, I thank you very much for watching this introduction to Windows executables, and hopefully see you next time.